Student, today we are going to learn electric torque due to the electric dipole placed in a uniform electric field. So uniform electric field is the electric field will be it's in a parallel line. Okay, the dipole is placed inside the uniform electric field. Dipole is going to be the equal and opposite charge separated at the small distance. Okay, the small distance we are taken as a 2a. I'll tell you what is the reason I am taken as a 2a. Okay, so we have to learn before start the equation. We should learn what is a torque, okay, what is a dipole moment, okay, and also what is a electric field. These are the three terms you should learn. Okay, the symbol first we will learn torque. Torque is equal to force into perpendicular distance. Okay, usually force into perpendicular distance, the unit of the torque we can take it as a Newton meter, because force unit Newton, torque unit meter. Okay, Newton meter. The first point we learned what is torque. Okay, the next one, dipole moment. Dipole moment, what is dipole moment? Okay, we have two equal and opposite charges. Okay, one is a plus, another one is a minus. Okay, distance between these two charge will be 2a distance. Okay, dipole moment, product of any one of the charge and distance between the two charge, we can take it as a dipole moment. Product of any one of the charge, anyone, it's maybe plus or minus, any one of the charge, and distance between the two charges, we can take it as a dipole moment. Okay, the next one, what is electric field? Okay, electric field is equal to force per unit charge. So charge, if you are taken here, force is equal to electric field into charge. That's what we can take it as a relation of electric field and force. Okay, now we'll be starting the equation. Okay, say I have uniform electric field. I placed dipole inside. Okay, uniform electric field, it's representing start from positive, end with negative. Okay, this side will be positive, this side will be negative, left side will be positive, right side will be negative. Okay, uniform electric field indicates start from positive, end with negative. I place dipole inside. Okay, this is minus and it is plus. Okay, plus will be creating force towards minus because force of attraction. Minus will be creating force towards plus. Okay, it's going to be F1 force, it's going to be F2 force, but F1 is equal to F2. Okay, distance between these two is going to be 2a. It is called dipole distance. Okay, now we will be learning what is torque. Torque is equal to force into perpendicular distance. Torque is equal to force into perpendicular distance. Okay, I place dipole at some angle, theta angle. Okay, so we can take it theta anywhere. Okay, theta anywhere, here or here. I am taken here. Okay, because same angle only. It is opposite and it is hypotenuse and this is adjacent. Okay, now we'll be seeing what is the force. Force is going to be this one. You can take it the F2 also. Okay, perpendicular distance is opposite of this triangle. It's going to be the perpendicular distance. Okay, again I am drawing what is the triangle is representing. So like this triangle will be there. It is theta, it is opposite, it is hypotenuse. Hypotenuse is going to be distance between the two dipoles and it is called adjacent. Okay, so opposite by hypotenuse is equal to sin theta. Opposite by hypotenuse is equal to sin theta. So now if you want, what is opposite? Opposite is equal to hypotenuse times of sin theta. Hypotenuse times of sin theta. Our hypotenuse is 2a. So 2a sin theta is equal to opposite. Okay, now opposite is called perpendicular distance from this diagram. Okay, it is called perpendicular distance. Okay, we know the torque is equal to force into perpendicular distance. Okay, if you are taken F2 force, this is perpendicular distance. If you are taken F1 force, this is perpendicular distance. I am taken F1 force, this opposite side only, it's a perpendicular distance. Okay, so perpendicular distance is called opposite side, which we found already. Torque is equal to force into perpendicular distance. Okay, our perpendicular distance is going to be 2a sin theta. Okay, so torque is equal to force times of 2a sin theta. So electric field is equal to force per unit charge. So force is equal to just cross multiplication, electric field into charge. So instead of force, we can write as a electric field into charge. So finally we'll get torque is equal to electric field charge 2a sin theta. Already we know 2a q2a. Okay, it's called dipole moment. 2qa, it's called dipole moment. Okay, p. Okay, so electric field is equal to ep sin theta, because this together will be in a P, dipole moment. Okay, next step, sin theta is there. Whenever sin theta is there, it's going to be the cross product. Okay, it's going to be vector product. So E vector cross P vector. Okay, so finally torque is going to be the vector quantity.